Enterprise blockchain is not just about processing correct transactions. In production, the network also has to survive failures, scale without becoming chaotic, and stay responsive under load. In this section, we'll connect scaling, availability, and performance tuning to practical design choices for production-grade Hyperledger Fabric. So far, we've moved from Fabric concepts through chain code development to deployment, CI/CD, and security. Now the focus becomes operational. Can this secured network scale, remain available, and perform under real enterprise workloads? From there, we'll move into monitoring and recovery. Before selecting peers, orderers, or database capacity, first define what the network must guarantee. In Fabric, that means translating business expectations into measurable targets: transaction volume, commit latency, endorsement latency, query response time, uptime, recovery time, and recovery point. A pilot may tolerate manual fixes and loose targets. Production cannot. Mission-critical networks need clearer objectives and stronger operational support. Architecture also depends on workload, because settlement, traceability, asset transfer, and document workflows stress the system in different ways. High availability is more than adding servers. It means preventing any single failure domain from taking down the network. Peers, orderers, CAs, databases, and load balancers should be distributed across independent zones, with replicated storage and separate network paths. Also look for hidden single points of failure, such as one load balancer, one node pool, or one storage backend. The right design balances uptime requirements with cost, risk, and compliance obligations. Peers carry much of Fabric's operational workload, endorsing proposals, committing validated blocks, serving events, and answering state queries. Adding peers can improve availability and read throughput, but only if traffic is routed intelligently. A gateway or load balancer should direct clients to healthy peers with the right role. Keep endorsement paths aligned with policy as well. Otherwise, scaling can unintentionally increase endorsement fan-out and add latency instead of capacity. A Fabric CA outage may not stop transactions right away, because peers and users can continue using valid certificates. But identity operations do stop. Enrollment, renewal, node replacement, onboarding, and emergency recovery. Treat the CA as critical infrastructure. Use highly available intermediate CAs, protect the CA database with replication and backups, and schedule renewals before certificates expire. Keep the root CA tightly protected while ensuring operational CAs remain reachable. Peer durability depends on protecting its storage layers together. The ledger is the source of truth, so a peer can often rebuild from blocks, but storage loss is still disruptive. Use resilient volumes for the ledger, private data, and CouchDB or LevelDB files. Replicate or snapshot them according to recovery objectives. If you use CouchDB for rich JSON queries, also plan for indexes, backups, restore testing, and private data recovery. The ordering service is where endorsed transactions become a shared sequence and are packaged into blocks. Because this path is critical, avoid relying on a single orderer. In a Raft cluster, the leader appends transactions to the log, followers replicate that log, and the cluster can elect a new leader if the current one fails. Place orderers across independent failure domains and monitor health, leader changes, consensus latency, and block creation to detect resilience issues early. Raft availability depends on quorum. The cluster must keep a majority of orderers online to make progress. With 3 nodes, 2 must be healthy, so the cluster can lose 1. With 5 nodes, 3 must remain, so it can lose 2. Adding a 4th node usually increases cost without improving failure tolerance. Treat maintenance as a quorum event. Upgrade 1 orderer at a time, and regularly test recovery from node loss, disk failure, network partitions, and leader changes. Fabric performance is a path problem, not a single server problem. A transaction can slow down during simulation, endorsement, ordering, validation, commit, state updates, or event delivery. Tune by measuring each segment separately: latency, queue depth, CPU, memory, disk I/O, network, and error rates. Don't assume that adding peers will improve write throughput. Test with realistic transaction sizes, endorsement policies, query patterns, and concurrency. then fix the stage that is actually limiting flow. Each required endorsement adds work: network messages, chain code simulation, and signature verification. Policies should match trust needs, rather than include extra organizations by default. The chain code path matters too. Expensive logic, repeated state reads, large payloads, or external API calls can slow proposals and increase failures. A practical tuning habit is to measure endorsement time, container resource usage, and proposal errors. Then simplify the policy or code where the data points. Batching is a tuning lever, not a fixed best practice. Larger blocks can improve throughput because each validation and commit cycle carries more transactions, but they may wait longer to fill and use more memory. Smaller blocks, or shorter timeouts, can respond faster when traffic is light, but they create more frequent commits and higher overhead. The right setting depends on real arrival rates, payload sizes, and whether the priority is throughput or latency. CouchDB gives Fabric applications flexible JSON queries, but that flexibility has a cost. If a rich query has no matching index, CouchDB may scan far more documents than expected, slowing peers and competing for resources. Design indexes around real access patterns such as asset type, owner, or status. When possible, use key-based lookups for predictable speed. In production, monitor latency, index usage, query time, and result sizes. Scaling Fabric works best when capacity is added deliberately. Add peers horizontally to improve availability, absorb read and query load, and distribute events without changing the overall topology. At the same time, every new organization, MSP, peer, channel, and endorsement rule adds coordination cost. Avoid creating channels for every relationship unless confidentiality or governance truly requires it. Private data collections and rich queries are powerful as well, but overusing them in high-throughput paths can create bottlenecks. Enterprise-ready Fabric networks are designed, not hoped for. Build redundancy across every critical service, size ordering clusters with quorum in mind, and validate recovery before it is needed. Tune performance through policies, chain code, batching, indexes, and resources. Next, we extend this operational foundation into monitoring, logging, backup, and disaster recovery.